Okay, so it's day 20, which means that I only have to do this 6 more times, and it's a point in the Advent season where I'm tired of doing this every night, and I just want to be able to like hang out with my family and like waste time online rather than um, it's funny. Usually I use coffee to like help me think during the day, but this happens 9 o'clock at night. I'm not going to drink coffee 9 o'clock at night, so it's especially taxing uh, for me to do these. I should probably, yeah. Anyway, uh, it's fun, but it's also exhausting. So it will be nice when it's done. 6 more days. Hopefully, I can solve them all. Yeah, it's possible I won't be able to, but we'll give it our best try. Okay, you notice a strange pattern on surface Pluto landing at one of the famous space warping mazes. Because there isn't much space on Pluto, civilization of your thriving in fully style. The technology is no longer understood. Mazes express all gaps of the maze is shaped like a donut. Portals along the inner and outer edge of the donut can easily teleport you from one side to the other. For example, this map of the maze shows solid walls and open passages. Every maze on Pluto has a start, the open tile next to A, and the open tile next to ZZ. Places also have portals. This maze has 3 pairs of portals, B, C, D, E, and F, G. When you step on an open tile next to one of these labels, a single step can take you to the other tile with the same label. You can only walk on dot tiles. Labels and empty space are not traversable. One path through the maze doesn't require any portals. Starting at AA, you could go down one, right? However, there's shorter path you want from AA to the inner BC. Come there. Walk to the inner DE, warp the outer DE, out to the outer FG, warp the inner FG, and finally walk to ZZ. Here's a larger example. Here, AA has no direct path to ZZ, but blah, blah, blah. So AA. Okay, so the hardest part is going to be parsing this maze. Other than that, I don't think so let's just start with here and let us do the following because I think this is going to be raw equals this. Okay. And so what do I want to do? I want to basically every place there's a dot is and let me get this lined up so that'll be easier. And I'll just strip it so that's fine. From typing import list dict named tuple. Okay. So as always, I will do class xy named tuple x int y int. So that's fine. And now, and what I want to do is I want to say class maze, which is a named tuple, and I just want to say start is an xy and end, which is an xy, and let's say neighbors is a dict from given an xy, it's going to give me a list of xy. Okay, so that's going to be how I'm going to represent my maze because I'm just going to I'm going to do again, I'm going to do a breadth first search, but what I want to do is I want to parse this into something that works. And so this parsing is actually going to be the hardest part. And so we're going to have to think a little bit about how that's going to work. And you know, I could do it by hand, but I don't do it by hand. I want to parse a raw string into a maze, and you know, I'll say lines equals raw dot strip dot split on new lines. And I want to do the following. First, let's find all, let's find all the portals. And so say portals is going to be a dictionary where the key is so we're going to say the key is a string, and the value is going to be all the dots that are adjacent to it. Okay, and let's so what do I want to do? I want to say for I see, and actually I just want to strip new lines here. And I'm not, or let me just do this, strip new lines, split on n, and then I won't do it down here. Okay, good. So we have this thing done. And let me say num rows equals len lines, and num columns equals len line 0. Just, we might want to use those. For I line in enumerate lines, for j c in enumerate. And let me just do this a set, and again I'm going to do deltas equals 0 1 0 minus 1 1 0 minus 1 0 and I'm not going to make this a static method. I'm going to pull it out just so I don't have that extra indentation. So parse something into a maze, lines, num rows, num columns. First, let's find all the portals. Okay, and so def neighbors loc, which is an xy, and that's going to return an iterator of xy. This is one of those things where it's shouldn't be that hard, but it is because it's just kind of nasty. And so portals set xy. So for JC in enumerate line. So I think the portals are all going to be capital letters. Is that right? So if A is less than or equal to C is less than or equal to Z, then for loc in neighbors x, y, I, j, so for d, let's say xy equals loc, for dx dy in deltas, neighbor equals xy, x plus dx, y plus dy. And again, I've got my xy's backward. It doesn't matter, but it's a huge irritation. And so if 0 is less than or equal to neighbor.x is less than num rows and 0 is less than or equal to neighbor.y is less than num columns, yield neighbor. So that should be fine. And so for the location in neighbors, and actually I only want to go right and down. So I'm going to go 0, 1, and 1, 0. So that way I don't get things twice. That's fine. And that's in fact better. If for I2, J2 and neighbors XY, C2 equals lines I2, J2. So I should call this IJ, not XY, but it's too late for that now. And just remember X is I and Y is J. If A is less than or equal to C2 is less than or equal to Z, then so let me just say portals, and you know what, I'll just make this a list. I don't think I need a set. Equals that. Portals, C2, that's the name of the portal, and I think they're always in the right order, equals, and it's going to be XY, IJ, I'll just actually do, I need to do it that way, XY, IJ, XY, I to J2, and then return portals. So let's just make sure I've gotten the portals right. And what is this? How did I get there? IPython. Could have sworn it's day 20. Anyway, so now if I run day 20.py, maybe name tuple is not defined. It's not defined. Could have sworn I did it. Let's try it again. Parse raw, and that's going to tell me that BC is at 9091. Oh, right. Okay. Because it's going to show up twice. From typing, no, from collections import default dict. So equals default predict list. Dot append this guy, and let me just extend rather. Okay, so let's try it again. Okay, so now BC has, well, DE got it right, and that's because they're both left and right. BC got 90 and 91, but it didn't get 9091, but it didn't get, so why is that not working? Print IJ C I2 J2 C2. Let me just do that. So at 90 I get B, and 91 I get C, so that's fine. And then I should get a B and C much later. This should be, so why am I not getting that? This should be like an 8. Why is that? Strip in. Okay, so something has gone wrong, and I don't know what it is. So that seems fine. For I line in enumerate lines, print line. Okay, what's wrong here? Oh, actually, it's fine. It's print IGC. So 19A 29A. So why would the 19? So deltas are 0, 1, and 1, 0, so that's fine. For dx, dy in deltas, here's equals x plus y, so over 1 over 1. I can't believe I'm wasting so much time on the stupid part of this problem. Where x equals 2, y equals 9, and that should be an A. So why is that not working? is it says 29. And why 9? Because I think I copied this wrong. Is that the problem? God damn it. I think I got the wrong number of... God, so stupid. No, it's 1921. All right. So that was totally caused by me copying the thing wrong, which is like incredibly moronic. I don't even have an excuse. It's just stupid. Stupid, stupid. So now AA is 0, 0, 1, 9, BC has 4, DE has 4, FG has 4, CZ has 4. And then, so let's do deltas 2 equals 0, 1, 1, 0, 0, minus 1, minus 1, 0. Okay. So deltas 1, okay. Okay. So now, what do I want to do? I don't want to return the portals, and I feel like I've probably used them in a stupid way, but that's fine. And so now, let me run this. Find start and end. So let's do this again. If C equals that, for loc in neighbors xy ij deltas 2. So I'm looking at its neighbors, and if loc in portals AA, then start equals loc. Otherwise, if loc in portals ZZ, end equals loc, and that's it. And then let's return start and end. So let's check that. And it's going to say that start is 1, 9, and end is 17, 13. Okay, so that's good. And now the only thing we need to do is and let's say portal neighbors equals this. And so let me do this. For portal locs in portals dot items, equal default dict list. For portal locs, if loc in lokes portal neighbors portal dot append xyij. So if it's a period and it's next to one of these portals, then and I'll just do that and return portal neighbors. And I think I was actually wrong before, but I think I'm right now. So so AA is actually 2,9, which is here. That's right. So start is the one neighbor of AA, end is the one neighbor of ZZ. Okay. And okay, that's good. And now the only other thing I need to do is I need to populate the neighbors. And so neighbors equals, again, default dict list. Okay. And let me do one other thing, which is neighbor portals equals default dict list. And neighbor portals xy ij append portal. So now we have a two-way mapping, and that's going to be helpful. And so once more, I'm going to do the following. Now find neighbors. So same loop as always. For loc in that. And I'm just going to do I2 J2 equals loc. C2 equals lines I2 J2. If C2 is a period, then neighbors loc dot append xy I2 J2. So it's a neighbor. I went to the other direction, so we'll get that for free. Anyway, and the other thing is so get direct neighbors and then get portal neighbors. So for portal in neighbor portals dot get loc and empty. So for each portal, and then for portal for neighbor in portal neighbors portal, if nbor is not equal to if that neighbor is not me, then I want to append that to my neighbors as well. Do I really have neighbors as a function and as a dict? Neighbor dict. That would have caused a pretty hard to debug error. Neighbor dict xy ij dot append neighbor. And now I can return maze where start equals portal neighbors AA0 end equals portal neighbors ZZ 0 and neighbors equals neighbor dicts. So let's try this. So maze where we have a start and we have an end and we have this neighbors where 39 is collected. This goes to 3929 3939. Okay, so that's bad. 310 goes to 310 310. Okay, so how is that even happening? 1311 goes to 1311 1211 15. Okay, so that seems really bad. Print IJ inbore portal. So let's try that again. Three nine is going to 29 through AA. 1311 goes to 1211 through FG. Okay, so this is like very wrong. So this is one of those bad advent of code days. 09A010, 09A19A, 19A. Why do I have those prints still? I don't need them there. Where did they? So let me just skip this part first and see what happens, because somehow that's going wrong. So 29, okay, so 39 goes to 393939. Okay, so I'm appending the wrong thing. For loc in neighbors ij, I2, J2 equals loc, C2 neighbor dict, loc. So loc equals xy ij for loc. I'm using really bad variable names, and that's causing me a lot of problems. I2. Okay, so now 29 has neighbor 39, 39 has neighbors 310, 49, and 29. Okay, so that looks much better. Now let's try and figure this part out. For portal and neighbor portals get loc and nobody. For neighbor, if neighbor is not equal to loc, neighbor dict loc append neighbor. Okay, so now let's try this again. And so at 2.9 we can go to 3.9. At 3.9 we can go. And so what's one of these that's interesting is like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 0 should be connected to somewhere that's not right by 9, 0. Maze equals this. Maze dot neighbors xy. I think it's 9, 2 actually. 0, 1, 2. And let's say raw 9, 2. Raw 9, 2. Raw dot split in 9, 2. 9, 3. So what am I doing? 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it should have been 8, 2. So 8, 2 goes to 8, 3, and 6, 9, and 6. Okay, so that looks pretty good. So I think that's okay. And so let's say maze equals parse raw. And now, what do I want to do? I want to, I need a queue, and let me just make sure that I understand this correctly. Shorter path. Okay, and I want to start and the end is open topic CC. Okay, good. So once again, we will write a breadth first search and def shortest path, which is a maze, which is a maze, and it's going to go to an int. And so q equals dec maze dot start. And I need to keep track of the number of steps. This is 0. And let's just say visited equals set, same as always. And maze dot start. Okay, and so while q let's say loc num steps equals q dot pop left. For neighbor in maze dot neighbors dot get loc, it has to be there because we got to it. For each neighbor, if neighbor is not in visited, then visited dot add neighbor, and q dot append neighbor steps plus 1 for if loc equals maze dot end, return num steps, q dot append neighbor num steps dot 1, and that should be it. So let's try it. Can import name q from collections because it's not called q, it's called dec. And what did I call it here? I called it right down here. And I have an extra print statement, but that's okay. Shortest path maze. And I did not ever get to the end. Print loc num steps q. So I've screwed something up again. Property object. Okay, so that's fine. Let's say print q. Let me just try this. What's that mean, property object? Print visited. Property, what the hell is property object? Um, I don't understand what's happening. Sorry, I'm having a really bad Python day today. Um, I don't deck q equals deck q dot append maze dot. Oh, I know what's wrong. Okay, God, I'm an idiot. Okay, I need to do lowercase m, uppercase m is the type. Okay, let's try this again. Okay, but it's still not working. But print loc num steps q. And now it's saying that 23 steps. So it ended. And how did it end? So let me try this. If nbor equals maze.end, return num steps plus 1, 23. Okay, good. So that 23 steps. Okay, so let us do escape. Copy. And I want to remove whatever print statements I have here, which I don't know where they were, but something's printing. With open day20.text as f, raw equals f.read, maze equals parse raw, print shortest path of maze. So let's see if this works. 448. All right. Let's try it. That's the right answer. Continue to part 2. Strangely, the exit isn't open. The normally recursive spaces. The mark connections are portals. They physically connect to the larger or smaller copy of the maze. Specifically, the label tiles around the inside edge actually connect to a smaller copy of the same maze. Those small copies. So when you enter the maze without this level, and the outer level, only the outer labels A and ZZ function. Other label tiles are effectively walls. In the other level, A and ZZ count as walls, but other outer label tiles bring you one level outward. Goal is to find you. First example above, the shortest path is now the loop around the right side. Starting level at 0, then taking the previously shortest path would pass through BC to level 1, DE to level 2, and FG back to level 1. Because this is not the outermost level, ZZ is a wall. I don't understand what that means, so let's think about this. The marked connections of the maze aren't portals. They physically connect to a larger or smaller copy of the maze. Specifically, the label tiles around the inside edge actually connect to a smaller copy of the same maze. and the smaller copies interleavable tiles connect to yet a smaller copy, and so on. When you're in the maze with the outermost level, when the outermost level, only the outer labels AA and ZZ function. All their outer label tiles are effectively walls. Any other level, A and ZZ count as walls, but the other outer labeled tiles bring you one level outward. Your goal is to find a path through the maze that brings you back to ZZ, the outermost level of the maze. In the first example, the shortest path is now the loop around the right side. The starting level is 0, then taking the previously shortest path would pass through to BC, DE to level 1. Another level. The only option is to go back around to BC, which would only send you even deeper into the recursive maze. In the second example above, there is no path that brings you to ZZ, the outer level. Here's a more interesting example. Towards path following, walk from AA to XF. Recurse into level 1 through XF, one step. Walk from XF to CK. So I go into XF, I come to this other XF, I go to CK, 10 steps, recurse into level 2 through CK, 1 step, walk there, recurse into level 3 through CH, walk through level 8, level 9. Alright, they're fucking killing me on this. So we're going to start by making a new file. Day 20 part2.py. And we're going to see what we need to do. And here's what we're going to do is we're going to so I find these portals, and that's fine. And then okay, find dots that are next to portals. And so here's what I'm going to do is I'm going to say inside portal neighbors, inside neighbor portals, outside portal neighbors equals default dict list, outside neighbor portals equals default dict list. And so let's think about this. And so now I want to do start and end separately. So handle start and end separately. So for this, okay. If loc in portals AA start equals loc, otherwise if loc in portals ZZ end equals loc, and that's all I'm going to do. And it's not asymptotically inefficient, but it's just like wasteful. inefficient. So find dots that are next to portals and so let's think about how this works and look at our maze. So if a dot is to the right of a portal, um, actually, no, that doesn't work. So how do I find out if a portal is on the outside or on the inside? So let's think about this for a minute. Okay, well, let us look at the big map and see. So if the portal is in the first two columns or the last two columns or the first row or the last row, it's an outside portal. Otherwise, it's an inside portal. Okay, so let's think about how to do this. Okay. For loc in neighbors. So let's say outside equals loc.x equals 2 or loc.x equals num columns minus 3. So it's got to be or loc.y equal and that should be num rows minus 3 or loc.y equals 2 or loc.y equals num columns minus 3. So if outside, and now I don't need this because there's only going to be exactly one of each of these. Outside, outside neighbor portals portal dot append loc equals xyij for loc 2 in neighbors loc delta outside equals loc 2 x is that or loc 2 or no, outside is x that and put it up here. And I don't even need to do this. I can say I equals 2 or I equals num rows minus 3 or j equals 2 or j equals num columns minus 3. For that, for portal locs, if loc and locs, if outside neighbor portals append loc, but I don't have to do append now because it's just one, equals loc, outside portal neighbors, loc equals portal, else inside. So now I have start end, and we're going to have to change this, but print start, comma end, print outside neighbor portals, print inside neighbor portals. So print inside neighbor portals. And parse raw, and that's going to do some stuff, but let's see what it prints. Oh, whoops. D20 part2.py neighbor portals is not defined. Let me just comment that out for now. One 9.7.13, and I don't want to. Okay, so that's not working. So let's find out why that is. IJ outside. So basically 2.9 is on the outside. 8.2 is on the outside. 13.2 is on the outside. 16.13 is on the outside. So that seems pretty good. And so let's see what I did wrong. Print loc 2, loc portal loc 2. Okay, so what am I doing wrong here? I should have a BC and a BC. So at 8.2, BC is 8.3. At 8.2, I have, but those are the two locations. So why am I not getting the direct neighbors? 8.2, 8.3, 8.2, XY 8.1 should be here. So that should be catching. If loc 2 in locs, okay, inside PCT, FGCZ. Okay, so that's good. And so and let us say two things. Now the neighbors, the neighbor dict, now each entry has to have a square and change in level. So so for the regular neighbors, the change in level is going to be 0. And now we need to do the portal neighbors. And so for the outside neighbor portals, neighbor dict loc append neighbor, and if I go through an outside portal, that increases my level by 1. And now I need to do the same for the inside portals, but for the inside neighbor portals, I'm going to do by -1. And so now I have that, and my types are wrong, but that's okay. So now let's look at the maze, and the maze says that I start at 1.9, I end at 17.13, and my neighbors are this guy 0, this guy 0. And then let's look at, my 8.2. 8.2 can go to 8.3 and 0. So why am I not seeing any maze.neighbors? Okay, so this is still not right. So let's print outside neighbor portals. Print I inside portals. So outside goes from this to this, this to this, this to this. So XY29AA 8.2 is on the outside. Oh, I see. Right, so I need to be even more clever here. For portal in, so now these are get portal neighbors. So if loc in outside neighbor portals, or let's just say, actually, outside portal equals outside neighbor portals dot get loc. If outside portal other loc equals inside portal neighbors outside portal, and neighbor dict loc dot append other loc, and if I go through an outside portal, I increase my, is that, let's see how it's said. Use the outermost level. Starting level 0, then the level 1. So outermost label will outside portal will decrease your level by 1. Inside portal equals inside neighbor portals dot get loc if inside portal the other location is the outside portal neighbors from the inside portal, and then that one will increase my level. And now let's try it. (8.2) goes to 8.3.0, so that's still not working. Print loc outside portal neighbors dot get loc inside outside neighbor portals get loc inside neighbor portals dot get loc. Okay, so that's not working either. So print O outside neighbor portals. So let's figure out why that is. Because it is, I should do it here once I've populated it. Okay, so outside neighbor portals, because I did these backwards, loc equals portal, portal equals loc, loc equals portal, portal equals loc. And I don't want to do AA and ZZ. So let me nope, that's not it. Okay, now 8.2 goes down a level. Okay, so I think this is good now. So let me remove this print statement and let me remove this other print statement and make sure I got rid of all those extra print statements. Okay, good. So now I need to rewrite my shortest path, and now for visited, I need to keep track of level, and let's do, okay, location level, and location level num steps, while q indentation level num steps equals cube pop left. For neighbor in this, if neighbor equals maze.end and level equals 0, return num steps. So we have to be at level 0 to end now. If neighbor level is not invisited, level, and now for neighbor, let's do this level delta, because we have this level delta. If neighbor equals maze end and level equals 0, return num steps plus 1. Otherwise, new level equals level plus level delta. If neighbor new level is not visited, add neighbor new level, q dot append neighbor new level num steps plus 1. Okay. So now let's see if this works. Shortest path maze. Okay, so that didn't work. That's good. Print loc level num steps. Okay, so this guy has no neighbors. And so why does he have no neighbors? He should have neighbors. Because he should have a neighbor who's right below him. But he should be, start should be 2,9, not 1,9. So let's see, maze.start, maze.start, maze.end, 1713. So, so I got start and end wrong. And again, it's because I used terrible variable names. Loc equals xy ij. For loc2 in neighbors, loc delta 2. If loc2 is in the portals AA and if loc2 is in portal, okay. So now let's try this again. Now it says 26. Is that what it was before? Shortest path is now the loop around the right side. Which is 26, which is the right one. Okay, so all right, let's try it. $4,016. That's not the right answer. Your answer is too low. Let's see if everyone else has solved this yet. Yep, they certainly have. one of those things where it's almost impossible to debug, um, unfortunately. Let me read the instructions and make sure I didn't get them wrong in some way. Larger or smaller copy of the maze. Legal tiles, smaller copy, walls at any other level, AA and ZZ count as walls, but the other outer label tiles bring you one level out. Okay, so I see one problem already, which is that I'm not allowed to, let's say, if new level is at least 0, and so I'm not allowed to go, negative on levels. So, and I would go negative on levels if I tried to go off the edge. So I might have found a too short path by doing that, is I guess the problem. So let's try running it again with that tweak and see. 5, 6, 7, 8. Okay, so that's definitely bigger than the first one. 5, 6, 7, 8. Submit. That is the right answer. Okay, good. So yeah, that problem's kind of a pain in the ass. But we got it, and I'm glad I got it in one video because that would have sucked if I had to get it in 2 videos. And let me look at this one thing. Hey, John, you're a big fan of named tuples. Can you train me to choose between that and a dict? So for me, I want to use a named tuple for structured data where I know the fields and I know the types. So here I have a maze. The maze has certain exact components, and so I want to use a named tuple for that so I can dot into it so my IDE can help me for it so I get type checking on it. I also have some places where I have an object with arbitrary keys and list of values, and I don't know ahead of time what the keys are going to be, and then I want to use a dict because so maybe that's a good quick distinction, is that if I have a mapping where I don't know what the keys are going to be ahead of time, then I probably want to use a dict. But if I have a mapping where I have a fixed set of keys and types and it's going to be immutable, then I probably want to use a named tuple. Anyways, that's my spiel about named tuples. I love using them. I use them all the time. You should use them too. All right, cool. I'm glad it's done, and now I'm going to bed. All right, see you next time.